Hello, people. All right, let me see. Yesterday's recording came out muffled. I don't know if it was using the wrong microphone or what. No, it's using the right microphone. I don't know, man. We'll see. So this initial stream is maybe it'll be an hour to an hour and a half, and then I'll get dinner and come back and stream some more. I have very minor snacks here, but let's see if these are even any good. No? All right. Okay, yesterday we did a stream where I started generalizing the animation, and one way of starting to do that was by making this file and parsing it and loading animations through this file, which uses these tags to refer to asset names. And that's all good. I did do a no-no, which is that I made a new file format without a version number at the top. So we'll remedy that eventually, but it's not important yet. And I want to get on to doing other things. So we still have a guy who can walk around and, go into different animation states like pushing and not. And as I've mentioned before, that's a very simple state machine that is hard-coded into the game in code. And so what I'm going to do today is move that into data. It shouldn't be too hard. So I'm going to make a new state machine struct that has a bunch of states, and I can add states to it with procedures, by calling procedures. And that'll still all happen in code, and it'll still do all this. And then when that's done, we'll start moving that into a separate file format from this one. And in the process of making that new file, we have enough text file formats floating around that it might behoove me to simplify the processing of them a little bit. So I may do that. I may make a thing that aids in chewing up text files so that I don't have to work quite as hard to do it. I mean, it's not like I'm working particularly hard, but there's just a little bit of fiddliness every time that I'd like to try to get rid of, given that there's a certain number of text file formats that we're going to be reading. So does that make sense to everyone? I mean, I'm obviously not going to re-explain everything in the world because, either you know how games work or you don't, or I don't know, I can't remedy that in one stream. All right, I don't see any particular questions. So let's let's start doing some stuff. I'm just going to make a new file. I'm going to go to my animations folder here. Oh no, not that animation, not the data animations folder, the source animation. And I'm going to make a new thing. I'm going to call it state machine. I call that animation state machine as far as the rest of the program knows, and you know that's a long name, so I'm going to say machine is kind of locally defined to animation state machine. I don't know why a state machine is called a machine, because state machines don't do anything. I mean, I guess the logic, it's the data layout for a state machine. I don't know, whatever. It's a graph with nodes. We might rename it later. And then I'm going to say, I don't know, animation. Well, I'm going to say node. What do I want to do for naming purposes? I'll do that. And I'm going to locally define node to animation to machine.animation node, right? Just so I have some good names to do things with. Let me add that. And let me go into here and load it. And we still compile. So that's already a minor victory. Why is... Yeah. I need to make a frequently asked questions on the Twitch page so that people can scroll down the page and see the answers to all these things, but I don't. Okay, so that's great. So what's an animation state machine? Well, you know, because I don't know exactly what I'm making yet, and I'm just kind of playing around with it, I'm not going to be particularly picky about, you know, efficiency in terms of processing speed or memory. Once I have it nailed down, I may optimize things a bit. So I'm just going to heap allocate stuff and whatever. You know, we're just spitballing here right now. So, you know, I'm just going to add a bunch of nodes. Each node is going to have an animation tag, right? That's a string. And that's a map into, or this is, tag is mapped to an asset name in the animation names files via, what was it called? Via animation. Loaded into I don't know, some level of description will be pretty good. So the node is just going to have an animation tag, and later we specify what happens if we go to other nodes. And we're just going to say nodes is an array of animation node. That's great. And, well, so I'm just going to put code in here that yeah. Yeah. Well, so what are we going to do? We're going to want to add a node to an animation state machine, right? Add node. well, we're just going to do that. Let's add a base. Well, for now, we'll add an animation name. Right, we don't know if every node, or animation tag. For now, every node is going to have a single tag. That may not be true later, but this is a simplifying assumption. Right, we're going to return the node because, you know, I guess I want to use the full names for readability. Like if someone, maybe I won't use these names. Like if this is an external API, like people maybe want to know what the types are called. I don't know, man. All right. So is this going to be a dumb thing? Node, new animation, node dot animation tag is copy string animation tag node return node. So that's fine. So I'm probably going to migrate the following thing into another file, but I want to make human state machine. This is going to be representing the state machine for human stuff. And it's basically going to have this stuff. So, well, let's just use the short names. We're going to return that, and we're going to add some states. We're going to say add node machine. Well, so basically our tags, if you look here, these things on the left are all our tags. So inactive was 1, active is 1. So walking, dead, pushing, pulling, active to inactive, inactive to active. Now, I don't necessarily like this. So there's a situation that's a little bit confusing because the state machine is so simple right now. You know, what's going to happen is people are going to add nodes with all kinds of random names, just representing whatever weird states that the character gets into. And they're not necessarily going to have a one-to-one relationship with these tags or anything. So I'm actually going to have, I'm going to have this have a name that's a string and an animation tag that's a string, and we're going to pass both of these. And I'm going to make the names something. It doesn't matter right now because this is going to be all replaced by a file later. Like I want to basically name them something a lot like these, but different. I'll just call them state with the same word: state inactive, state active, state walking, state dead, state pushing, state pulling, state A to I, state I to A. Okay, so that's fine. And then this is going to take a name. Well, that's fine. You should see rectangle style, use rectangle style selection. Yeah, I mean, just when it comes to editor stuff, I'm pretty fed up with Emacs, and I use the minimal amount of stuff. Like, Emacs can do all sorts of great things, and I'm just never going to bother learning all those things because they're all annoying and they don't work well enough and consistently enough for me to put effort into. So I just, like, I used to know a lot more weird Emacs stuff than I do, and I've just been forgetting it over the years because I don't care because it all sucks. Yeah. Would I let less comments on my code after I finish the game? Or for you, it's not that important? I don't understand the question. It doesn't look like there's very many comments in my code right now. Okay. So what I'm thinking about now is do I try to make the arcs for all these things? Yeah, let's have some notion of an arc that goes. So for example, the idea is that the game is never going to tell the animation system, go play the active to inactive animation, right? What it's going to do is, if you're in the active phase and it says, well, it sends a message that now we're going to go inactive, then instead of jumping straight to state inactive, we're going to go to this active to inactive and stay in that state for a while and then go into the state when we're done. So we actually want well, let's say there's a thing called an arc, and well, it's the destination. And we'll just have it respond to a string message, possibly. If we see this message, we go to this destination. This is all probably going to change heavily, right? So each node has, well, we can say arcs, message arcs. These are the ones, if we get some message about going to a new state, right? And if we don't get such a message, when done, so if the animation finishes, these are pointers, because we're just going to new these arcs all over the damn place. So if this is null, the animation will repeat, will stay in this state. Right? right. I've typed some things. There's probably something wrong already. Remember, this bucket array is a spurious error that I haven't fixed yet. Undeclared identifier animation node. Oh, right, because... Oh, God, yeah. Pointer versus non-pointer. Wanted... Oh, really? Wait, where? Line 24? Right. I'm just using pointers to everything right now because we're just going to be super inefficient. All right, this is good. Okay, so I'm going to start using these. I'm going to say active to inactive, right? Oh yeah, we don't have a built-in new anymore. Done dot, what did I call it? Just destination. Destination equals inactive, right? And inactive is here, active is here, right? And I to A is this. I to A dot when done is new arc. I to A dot when destination equals active. Well, let's do this. Add arc A to I. Inactive. So we're going to have this add arc routine. Add arc I to A, active. So when we add an arc, source node destination node message. The message by default is going to be the empty string, and if it's the empty string, then if there's no message, then source.when done, arc.destination equals destination. Then this is the when done arc, right? Else arc.message is copy string message, and array add source.message arcs arc. So we can sort of call this routine in two modes. And if source.when done log print add arc, give more of an identifier than that. Attempt to add when done arc to state, but we already had one. I have a name, right? Yeah. Destination node is undeclared identifier arc. Aren't I worried to spoil too much by showing code and even gameplay? No, I'm not showing the good part of the gameplay. Are you kidding? if I ended up fixing the compiler bug with the colon equals syntactic sugar. So the bug wasn't actually the desugaring like I was talking about. It was just, I mean, that desugaring is still not ideal, and I should take care of it sometime. But the actual bug was just like I wasn't copying a value when I polymorph. It was a very basic bug. It took like 2 seconds to fix. Okay. Okay. Well, let's check some stuff in. Machine. All right. So I have to decide now. So most of these states what I have to do now is make a way for the game to interface with this thing. Like we've already sort of said, well, maybe it sends string messages to it. And that's fine. But most of those messages right now need to have the effect of jarring it into different states. So I think when I send a message, it needs to have some information about, okay, if there's no handler for it, like if the node doesn't have an arc that responds to that particular message, then voila, we just jump there. And so right now, again, because I think I'm going to name my messages basically like the states, except I'm just going to call them, I want to call them gameplay state or whatever. Okay, so if I'm in inactive, right? So I'm going to add an arc to inactive that takes me to inactive to active fill-in animation, right? If we get the message, go state active while we're in that state, right? And if we're in the active state, we want to go to the inactive state if we get a go state inactive message. This is confusing because there's a lot of there's 3 different kinds of strings floating around now, right? There's this one, which is the name of the node. There's this one, which is the animation tag that happens on that node. And then there's these ones, which are the messages. All right. Well, yeah, whatever. Whatever. So I guess now I start trying to use it. Have I ever run into friction in the new language that inspired me to change something right away? No, I mean, things are far enough along that usually I just work around something, because doing something too impulsively is not that good of an idea, right? So, I get an idea of something to change and I let it simmer for a while. Why do these things have string names? You mean the messages or something else? The nodes? I mean, the reason is because someone's going to be referring to all these from a file, so they have to have string names at some point. Now, these messages may later become integers or something. That's probably a more efficient way to do it. But like I said at the beginning of the stream, I'm not worrying about efficiency right now because I don't know what I'm building, right? Trying to worry about efficiency when you don't know exactly what you're building is a bad idea. We can always, it's trivial to later, well, not completely trivial sometimes, but it's pretty easy, all things considered, to go in later and say, you know what, these would be better if they were a fixed set of enums, and to do that, right? But I don't know, maybe the messages are gonna be dynamically generated in some way. Maybe, so there's another thing when I was talking to the animator that they probably want to be able to investigate a limited set of variables, but it's unclear how you refer to those variables, and because it's unclear, it just adds more of a cloud over all of, like, maybe the variables and the messages are somehow the same thing. Maybe they need to be different things. I don't know. Like, that's why I'm building this. So, yeah, hopefully that makes sense. Okay, so this state machine that we've put together here is now going to be the same for everybody. And then the human animation state. All right, so let's start looking at, so this thing that has these enum states is now going to be in these kind of nodes. You know what I'm saying? So someone's asking, how do you usually write objects like NPCs, monster, troll, dwarf, whatever, without using classes? Specifically, how do you pair functions with objects like is usually done with methods? Perhaps I have an array of NPCs and I want to run their individual update functions. So first of all, so it's not that hard to do that. Like, you can have a function pointer, or you can have a function that dispatches in a hard-coded way based on the type of what it's looking at, which may be better for performance. But I'd like to just say that the question itself is very leading, because what you're asking is, if I want to do things in the way that I learned from object-oriented programming, how do I do that without objects? And what I'll say to you is, maybe that's not the best way to get work done, right? Maybe you should architect your program in a different way, possibly. Maybe you should at least think about it. You should think about what other ways could you write the code. That's all, right? So, I mean, and I'm just saying that not to pick on the particular person who posted that question, but just because it's a very common format for a question, right? People have sort of been taught to think in the C++ style of object-oriented way, and they see all the programs they have to write in terms of that pattern, and then they say, how do I do that pattern in something that's not built for that pattern? And I say, well, you can do it, but why exactly are you doing that pattern necessarily? Yeah, we've already got console variables all over the place. That was taken care of long ago. Okay. Is the stream still going? The chat died. Yeah, okay, the stream's still going. Yeah. So I've got a procedure called animate. And this thing, you know, it's basically got a switch statement here that does stuff. And what I'm going to do is I'm going to make animate just be a wrapper to the state machine. And it's going to kind of act as a little bit of dead glue code for a little bit, and then we'll abstract it out, right? So here's what we'll do. If bang human state machine is make human state machine, right? And we're going to say okay. So everything I'm guessing from here down is not right. And we're just gonna do a new thing. We're gonna do the following. Because the gameplay is still, these things, well, these things are now gameplay states, which are going to be different from animation states. So there's going to be more states flying around, at least for a while. And I'm going to say, all right, so just so I have a short name to refer to it. So for inactive, I'm going to send a message to the state machine that says go state inactive, and state inactive is going to be our default of if nobody handles that, right? And all our things are going to be simple things like this. Nope, not lacking. Are you lacking right now? Can't type. All right, so that's fine. And then over here, message is a string, default state is a string. And again, maybe these should not be strings ultimately. They probably won't be, because later, well, I don't know. Yeah, I mean, for speed purposes, right, I could look up these states ahead of time and cache the pointers to the nodes and just send you the node, right? But okay. So we're missing something, which is that we need the, so this state machine is going to just be it's not really a state machine because it's just the structure of the graph. Maybe we'll rename it to animation state graph later or something, right? Maybe animation graph. And it's confusing because we have this thing called a human animation state. And that also has the words animation state in it. And it makes it hard for things to think about. So you know what? Okay. Let's make sure this compiles and then I'll rename some stuff. All right, so animation state machine is going to be animation graph, right? Maybe it should be called animation control graph. I don't know, but it's animation graph right now. Right. Rename it in both files. So, all right. Let's call human state machine human animation graph. Okay, so now that's just going to be the graph of how we transition around, and this human animation state thing is going to be there's going to be one separate copy of these per character in the game that controls, you know, where we are in the graph, right? So we're going to say node index is an int. This is which node we are in inside the graph. I could make that a pointer to the animation state, but we're going to want to hot load these, and your state may go away, and we want to detect that. So we're going to say, we'll worry about hot loading later because after everything's done, because we want to be robust and like keep your animation in the same state even if the states have been reordered and whatever. So we're going to want to remember the name and all that good stuff if we're in developer mode. So that's going to be a little bit interesting. We'll save that till after this stuff works. Someone's saying, you've seen it develop without a debugger. Do you not use a debugger in your other programming? I use a debugger a lot with this. Yes, I mean, look, when you're building a programming language, you only can do so much at once. We ostensibly have debugger support. It kind of works. It doesn't totally work. And it'll get good eventually, but I'm just not... I'm just not in the habit of using it yet, also, honestly. Like, if a hard problem comes up, I'll use it, but in the debugging that's happened so far, it hasn't really been a hard problem, right? The thing about debugging is, like, Visual Studio is the best debugger that I know of, but it's really pretty crappy at this point. I mean, it's way better than trying to use GDB or something, but it's bad. So I don't, you know, given an excuse not to use it, I won't use it also. I would, in the long term, like to make better debugging facilities that are actually reasonable, given the modern state of computer technology. Since nobody else seems to want to do that, but I can only do so much at once. Yeah. So we're just gonna, okay, we're gonna keep the node index, and then, you know, animation time we will know because of the animation that's on the guy and all this stuff. So we're going to have some interesting things like your default node index is 0, blah, blah, blah. All right, so when I say send message, I need to pass the human animation state. All right, I already have that. Okay, so now we won't want this to be human animation state, but a more general struct that to take a substruct that applies to any animation graph. Okay, so we'll call that default node because this is going to be called state and they're different things. All right, so we send a message, and the way this works is we're going to assert for now state.node index greater than 0. Assert state.node index is less than m.nodes.count. Eventually, right, because you could hot load and you could delete the node that someone's in and whatnot, and yeah, as I mentioned. All right, so current node is get node from the machine by, well, current node m.nodes state.node index. Let's call that, yeah, let's call it current node. And for current node, call it arc, current node dot message arcs, if arc.message is equal to message, then we do something and break. Do I have a short name node? Yeah. Okay, so destination equals arc.destination and break. If we didn't get a destination, then the following happens. Node is find node by the default node name. We'll call this default node name. Right? If you didn't get one, log print send message oh yeah, I should replace the word machine here. Animation graph send message says attempt to use default node name, but no such node exists. And we'll just return. Okay. So switch to state. Let's have destination know what node index it is so that we don't have to redundantly pass a node index. Switch to state, state, and destination. This is still called machine, which is weird. I'm going to name it graph. Yeah. Okay, so switch to state. Of course, it's still called M. We're going to say state.nodeIndex. Is it called node index? Yeah. Equals destination.myNodeIndex. Let's call it node index. Why not? Oh. We need a way to play animations. We need a way to play animations. Do I put a callback? What do I do? Well, let's put this node index in. Incomplete. Play animations somehow. The node index so when we add node, we say node dot like that. You're not passing the default node name to the log print. Thank you. This is probably a good time to make sure we still compile. Probably don't. Definitely don't. Oh, make human animation graph. Renames are never as simple as you want. Okay, find node. We don't have that. So let's make find node. Simple enough. Find node graph. In fact, let's go replace M graph. No, let's not do that. Let's just, if we're going to call it M for a while, let's be consistent. Find node name string. Right, so for m.nodes, if it.name is equal to name, return x, otherwise return null, and this is a pointer to nodes. All right, is the game still run? Okay, but we have no animations yet, because like I commented all that stuff out, and we're sending messages to our graph. Let's actually see. So what we need is a way to get back and call animations, but in the meantime, we should be able to say print switch to state. No, not state.name, destination.name. Okay, so walking active. Walking active, pushing active. Okay, that's all good. So now let's see. All right. So I'm going to switch characters. So the red guy should go. Yeah. So one guy got active to inactive and the other guy got inactive to active. But, of course, we're not so there's two things that need to happen, right? If you're in this state, the way you're supposed to transition out is when your animation is done, which we don't have a way to signal that yet. So let's do that. Before we even can see the animations happen, I'm going to have a call called animation is done. We're going to do this same stuff. And then we're going to say this is not the right way to do it, because we need to know let's not do this yet, because we don't want to wait till an animation is completely done and then transition to another one. You want to like cross blend them. So you want to know what state you're going to transition into and cue that up early. And I'm going to need to think about that. That's probably think at least a little bit about it while I'm eating dinner. So let's actually make the animations visible in some way. Let's just put a callback, right? I mean, what the hell? Why not? Okay, so well. What needs to happen? So we need to look up the, let's go back over here. Okay, remember we had this, we got our set of names, which maps the tags to the animation asset names. Right, when we instantiate one of these characters. And we're setting our pointer into it. It's not necessarily that useful of a thing anymore. I mean, it's fine because we did this knowing that it would be deprecated eventually. Anyway, so what we're going to really want in order to do anything useful is we're going to say names is our animation names. We'll call it animation names. All right. So we're going to say s.animation names is names. Okay, that compiles. I think we're not using these anymore. Oh, we're using them. right. We're using them elsewhere. We may not be using this. Let's see if we can get rid of that. Yeah, all right. Wait, what? I guess I didn't correctly save the file, or Emacs took too long to save it. I'm not sure what happened there, because let's look at what that is. Oh, that's just this. Okay, this is just, okay, let's try. This is just getting the guy into his initial, this thing right here. It's just saying, oh, put the character in his inactive state. But we actually, in a separate place, loop over everybody at the start of a level and tell them to start animating. So that's actually not that useful anymore. Yeah. So now I feel like anyone who tried to use that animation set is maybe old code that, yeah. I mean, someone who's pulling, those if clauses were just to make sure I don't try to dereference an unused animation, but since we're moving to a looser data-driven scheme, that kind of thing will fall out in the back end. All right, so, well, I just checked in a version of the game with no animations. Whatever, guys. All right. So, oh, this is called state machine. Let's rename this file. We're going to call it graph. Rename file. All right. Where are we at here? 128 lines. So we've already done 12.8 days of work at the industry standard 10 lines of code a day. That's not fair because it counts white space. All right. So I'm just going to do the work right here, and then we'll factor it out. Because, you know, we're only using this for one thing right now, so we know exactly what it is. So I'm going to say guy is state.guy. That doesn't exist, so I'm going to have to make that pointer. It's a pointer to the guy. And, whoops. So back here, we used to call play animation on the thing. So we're going to look in the names, right? Remember we had this animation names from yesterday. We're going to assert guy.names, let that got set. We're going to say animation name is guy. What does our table do? It's table find. Table finds guy.names.table. And then the key, which is just going to be our, what was it called? Animation tag. Node, or destination, animation tag. Right. Oh, and found. If not found, log print, switch to state, animation graph, node, whatever, told us to switch to animation tag, whatever, but we could not find. So our animation names, we could not find a binding for this tag in animation names, whatever, right? So destination.name, destination.animation tag, and guy.names.name. And we return under those conditions. Otherwise, we play animation. Oh, no, we have to get the animation. Unable to find animation catalog. Animation name. Return. Otherwise, we keep saying play animation, guy, animation. I'm pretty sure I have an overload of play animation that takes a string name. But whatever. We can refactor to that later if we want. All right. This is good. I needed to make on human animation state our guy pointer and reset that. S.guy is guy. Names is not a member of guy. Oh, it's called animation names, isn't it? It's not a member of guy. What? Oh, it's on the human animation state. I don't know if that's the right place for it, but we'll just leave it there. It doesn't matter that much right now. Okay, so S, so names. All right. Not names, names. that's not a pointer. Yeah. Procedure call did not match any of the possible overloads. Yep. Oop. Names is not a member of Guy, right? Guy.names. Names. All right. Well, I don't know what that's going to do. Hey, look, he's animating. Hey, look. How awesome is that when you put together the system and like it works the first time? We just replaced the hard-coded thing. Well, let's see what happens with two characters. Oh my God, he went into the, okay. So these things are looping, so we didn't do that yet. But, I mean, we're in a pretty good place right now. Like if I wanted to go get dinner soon, which I do, this might be a good time to do it and then come back and stream again later because we're doing pretty good. See, because you notice it's even doing the transitions according to message, right? So the red guy is currently inactive, and when I switch to the blue guy, he's going to go to inactive, but it's going to see the message and say, oh, when we're inactive, instead go to this active to inactive animation where I fold my arms, right? That folding his arms isn't one of the gameplay states. It's, see that? Of course, unfortunately, loops right now. So we're going to have to figure out whether the user designates whether it loops, or maybe it automatically doesn't loop if there's a, it probably automatically doesn't loop if there's a, yeah, let's see. Oh no, because, you know, I need to solve that problem about, you know, knowing where we're going to branch into ahead of time. Maybe I won't really solve it, but whatever. Are there any questions for a couple minutes about what just happened before I go get some dinner time? I'm scrolling back in the chat. Am I going to do all the programming for this game? I don't know. I've done it all so far. We'll see eventually about whether somebody else. It certainly wouldn't be bad to have help, but the good thing about me doing all of it right now is I'm really keeping it real. And like, if there's problems or inconveniences with the language, then I'm seeing them and I'm forced to confront them and figure out what to do. So that's good as for me as the language implementer. How might I solve the problem of branching into other animation states? I'm not sure. You'd have to be more specific about what exactly the problem is that you're saying. Because I don't know what you mean. You mean like having alternatives of like maybe there's 4 different ways to do a jump animation? Do you mean that kind of a thing, or do you mean something else? Do other programmers on the team write a lot in this language? No, I'm pretty much the only person who does right now. Everybody else is on other things. I need to do some more witness-related programming, which maybe I'll stream some tomorrow. That'd be fun. Is data-driven a good approach for a single programmer? I mean, I'm not sure, like there's a lot of ambiguity in that question, and I'm not sure what you mean. But if you mean, as a single programmer, you can only write so much code or whatever. The style in which you see me programming is the one that I find to be the most productive for me as a single programmer, right? If I thought that I could get more code done and it would be higher quality and I would get it done faster if I did all sorts of crazy object-oriented stuff or crazy functional stuff, then this programming language that I'm making would be a crazy object-oriented or functional programming language. But it's not, and my style also is not, right? The style that I'm programming in is, what I have converged on after many, many years of programming, right? 21 years of professional games programming, and then hobbyist programming for, I don't know, how old am I? For another 14 years before that or something, right? So it doesn't come from nowhere, is what I'm saying. Will you be able to make HTTP2 request with the standard library? Probably not with the standard library, but like with a library, sure. Probably one that we provide, yes. So I'm not taking the C++ attitude, which I think is really bizarre, which is that everything in the universe has to go into the standard library. Like that doesn't make any sense to me. Because I think the only reason that happens is because there's a C++ committee and the committee wants to expand what they have purview over. So everything goes in the standard library. I don't think that makes sense. Like focus on making the language good and let people make good libraries for it. Of course, you should have a basic library that provides things that people want to do. But for something like HTTPS, like that's complex enough that I don't think you would call that standard. I mean, I think you call like opening a file and doing stuff to it standard. Oh, you said HTTP2, not HTTPS. Well, I don't know. I mean, an HTTP request is just you open a TCP socket and write some text. It's like not hard. So do I feel like I'm running with scissors when I change the compiler, or is it pretty stable at this point? Once in a while, I do things that are a little bit destabilizing, but it's mostly stable. It's been pretty good ever since I did the polymorphism cleanups, especially the latest one, but even before that. Like polymorphism was the one feature that was pretty scary. And, it grew to be a very complex thing as I built out the original feature set. But then like any good puzzle game like TIS 100 or Shenzhen IO or something, you keep working on it and you figure out ways to simplify your solution and make it better. And I simplified polymorphism down to where it's not scary. That said, I did make it slightly scary again with some of the changes that I made for the next demo that's going to happen this weekend. So there is that. But then that'll get simplified out again too. So it's all good, really. Oh, HTTP2 is binary. Okay, but I mean binary, whatever. Binary over a TCP connection is pretty straightforward. All right, I'm getting dinner. Thanks for coming by. I'm probably going to start up again maybe around 9 or maybe a little earlier. I don't know. And we will continue with this stuff. See ya.